Today we're going to be working on Van Haley's levels of geometric thought. And so for this first activity, it's going to be a level 0 activity because it's going to be focusing on visualization. So students are going to think about the shapes and what they look like, but they aren't going to know exactly the terms that will be used to describe them. Alright, so this is my kindergarten class. Right now we have 17 shapes. Who can tell me which of these shapes are circles? Good. So right here we're going to have this one, 1, 2, and 3. How did we know that they were circles? Because there are no lines in these shapes. So let's look at some real life examples of what a circle could be. Here's a coaster. You can see that the circle on the paper and this coaster are different sizes, however they have the same shape. Another example is a candle. So although it's a different shape and it's a different size, it's the same idea. It's not going to have any edges. Next, who can tell me what a triangle is? So it'll be something that has 3 sides. Who can tell me which of these shapes is going to be a triangle? Good, so we're going to have this one right here. 1, 2, 3, 4. Do you see any more? And there's one more, 5. So how do we know that these are triangles? Oh, and here's one more, 6. We know that these are triangles because they make a shape that goes out, down, and across. So it'll make 3 lines will connect. They don't all have to be the same shape. But how do we know that this one right here, that's upside down, and this one that's right side up, how do we know those are both triangles? Good, it'll be because they're the same shape regardless of which direction they're facing. Lastly, let's look for some squares. Which ones do we see that are squares? Good, we have this one. Oops. We have this one right here, and then we have this one right here. So how do we know that these are squares? Good, because they have 4 sides. So what's the difference between this one right here and let's say this one right here? They both have 4 sides, but this one is equal. 4 sides that are all equal sides, and this one, these sides right here are longer than the width. So this would be a rectangle, right? Yes. Good job. So that's how we can determine what shapes look like by using real life examples. So let's use an example. What is something that could be a rectangle? Here, right here, is just a Post-it. An index card. So here's an index card. Although it's a different shape or a different size, it is the same shape. All right, next we'll move on to a higher level of Van Haley's geometric thoughts. Next, we're going to be looking at level 1 of Van Haley's levels of geometric thought. So in level 1, the students are able to describe the attributes and shapes and compare and contrast by finding similarities and differences between them. And so we're going to be looking at these different shapes right here, and then the students are going to be able to tell me, based off of what they know about triangles, which triangles fit the criteria to be an actual triangle. So let's go ahead and begin. So let's look at this first one. A, is this a triangle? No, it's not. Why is it not a triangle? It has 3 straight edges, but what's wrong with it? There's this gap right here, and so we know that in order for it to be a triangle, it has to connect all the way. Each side must connect and then have those 3 edges. So A is not a triangle. What about B? Why is B not a triangle? Good, because these sides right here are shaped in like an arc, and so they are not straight. So these sides are not straight, even though this bottom one is. So B is not a triangle. Next, let's look at C. Is C a triangle? No, why is it not a triangle? It has this flat side right here, and it has 3 sides all together, but what's wrong with it? Right, these sides right here are shaped outwards. They're not straight sides. So while B was in, this is out. So again, this is not going to be a triangle. Now let's look at D. So let's see, D has 1, 2, 3, 4 sides. So what do we know about triangles? There can only be 3 sides, not 4. So we can automatically assume D is not a triangle, even though it has the points on the outsides of the shape. Let's look at E. Right now we see there are 3 straight lines that all connect. Do we agree that this is a triangle? Yes, good, because those 3 sides connect and they're all straight sides. What about F? Yes, why is F a triangle? Good, because there are 3 sides and they are all connecting and they are straight sides. So this way, students at level 1 are able to recognize that E and F are valid triangles based on the attributes of a given triangle. Next, we're going to do another example about level 1. So again, the students will be recognizing which of these shapes are going to be squares and which are not. So let's begin. Let's look at this first figure, figure A. Is this a square? Yes. How do we know that it's a square? Good. There are 4 sides. 1, 2, 3, 4. And what's something else we can do to know that it's a square? Good. We can draw a little right angle right there so we know that's 90 degrees. So good. This first one is going to be a square. Let's look at B. Is this a square? No, why not? It has 4 sides, and they seem to be equal, but right here, that's an open space, so we know that squares must connect in all 4 edges. Let's look at figure C. So we can see that there are 4 sides, and we can draw our little right angle box. But why is this not a square? Right, because the height and the width are not equal. So these are equal to each other, but these are not equal to each other. So this is a rectangle, so that is not a square. What about figure D? It has 1, 2, 3, 4 sides, but it is not a square because they are not equal sides. So D is not a square. What about E? Right here we can draw our little box. 1, 2, 3, 4 sides. Is this a square? Yes, good. So right now, so far we have A and E are squares. Let's look at figure F. Is F a square? It has 1, 2, 3 sides. So we know that F is not a square because we already know that squares have 4 sides. So good. This lesson shows again level 1 of Van Halen's levels of geometric thought.